Hey there, welcome. Good day. Slope fields. That's what we're going to learn about today. This little brief message. There's a picture taken in just outside of Savannah, Georgia. Thought it was cool. So what's a slope field, you might ask? If you didn't, I'm going to tell you anyway. So when we're talking about slope fields, let me go large screen, much better. What I've got is I've got a bunch of parabolas. You might recognize them. I just got them all stacked up together on top of going up and down the y-axis. And so what we're going to do is I'm just going to draw little tiny tangent lines all the way along the thing. Okay, so a little tangent line there. If I drew a tangent line, let's say about here, and about here, and about here, and about here, and about here. I'll just kind of go through and do the rest about keep saying here and here and here, but then did it again. So you notice I'm sort of tracing along the thing, but if I were to extend it both ways, I would have myself I would be drawing the actual tangent line, okay, right? So I'm just sort of drawing a bunch of them in. Takes a little time to do. It wasn't really tangent, it was me being on top of it, okay? I'll do a couple more on this side so we get a really good visual and be prepared to be amazed. Okay. Good, I think. Good enough. Yeah, that's okay. Yeah, that'll be fine. All right, so then what I'm going to do is I'm going to grab my pointer back and I'm going to make what it looks like just a bunch of dotted lines into a slope field. Ready? Neat. Let's do this. Ooh. Talking to myself. It's okay. Delete. Okay, you notice what's happening? Oh, I don't want to do that. Oh my goodness. Like that. Delete. Delete. So what's left after I get rid of the curves is just a slope field. Okay? And slope field is just a graphical, I'm sitting close today, I'm sorry, representation of the derivatives for a family of functions. So that's what we've done, is we just took the derivatives, the tangent lines, and we put them all in here, and we've got, and if you were just to see this slope field, you would see, oh, hey, it looks like a bunch of, you might be able to pick up that there's parabolas in there. I'm sure you'd be able to do it. I know it. Okay, so slope field is a graphical representation of the derivative of a family of functions. So let's try one, okay? So y dx equals negative x over y. That's my derivative, and I want to find out what the slope field is. So if I start with 1 comma 1, that means I put x is 1 and y is 1, I get negative 1 over 1. And so negative 1 over, or I'm sorry, 1 over 1 is 1 and negative 1. So at the point 1 comma 1, I'm going to draw a little dash that has a slope of what we're going to consider negative 1. Okay? And we'll repopulate this with all of the fields. What I would suggest you might do on your paper is, we'll do one or so more together. We'll do one more together, and then we'll have you guys go. If I were to do 1 comma 0 when x is 1 and y is 0, when x is 1, y is 0, I get 1 over 0, so I end up with what we're going to consider a vertical line, right? If I do negative 1 and 0, like over here, I'm going to get a vertical line. What you might realize quickly is that every point on the x-axis is going to give me a vertical little line, right? And we'll go a little bit there, a little bit there. Okay, what's going to happen on the y-axis? On the y-axis, when x is whatever value, or x is 0 and y is whatever value it is, I'm going to have 0 over some number, so I'm always going to get 0. So along the y-axis, all my little slopies are going to be horizontal lines. Okay. It's fine detailed work. And then if I just pick some points, if I go negative 1, 1, like right back here, negative 1, 1, I'm going to have negative 1, over 1, but it's going to be positive, so that's going to give me a slope of positive 1. And if I go through and do the other calculations on these 1 points, this one's going to be a negative 1 slope, and that's going to be a negative 1 slope. And it doesn't really matter that it's perfectly negative 1. What we want is the general idea as we go to be the case. And so what I'm going to ask you to do is just pause for a second. I'm going to stop recording for a brief second. I'm going to fill in the rest of these with a different color. You pause for a second and fill in what you know, and then we'll compare what we have, and then we'll talk about what it means, what it tells us, and where we go. Okay, so I'm pausing. You should too. All right, so I started filling in some of these, and the basic thing that you want to be aware of is that, like, as I'm going along here, we don't need to calculate the slope at every single point. We need to look at the trend. So when y stays the same, as I move along, as I move this way, let's see, as y stays the same and x gets bigger and bigger, then my slope is going to get steeper and steeper as I go through, okay? And then as y gets bigger and x stays the same, my slope's going to get smaller and smaller. So, you know, I can start to fill in a lot of these points just by going saying, okay, so as it gets taller up, that these are going to get to be less steep. So, you know, a little less steepish there, and then a little less steepish there, and they kind of flatten out. And hopefully you might see what's going on here. What kind of pattern we have is that you can see, maybe you can see the shape. Can you start to see the shape emerging? What's going to happen as we get through there? You might suggest that what we're going to get is we're going to get a family of circles. Okay, see where the circles might fall in there. And so that would kind of be the slope field that we would see from this sort of thing. And if I'm not doing it, if you're doing it a little bit, a little more attention to, I don't know, a little more penmanship ability than I have right at this present moment, that might be what you'd see. Okay, so see the idea? We just would fill in the things, and we're just looking for trends. Notice, like along here, they all have the same slope along this y equals x line and along the y equals negative x line, because the x and the y value are the same in this case. Okay, general idea. Filling in some numbers, looking away. So from that, we got dy dx equals negative x over y. We filled in some slope field points, and then that turns into a differential equation. The derivative is equal to negative x over y. And so what we want to know is, of course, what is the original equation? And how do we do that? Why, we separate our variables, right? So separate the variables and see what happens. So when we separate the variables, this is a nice one to do. We're going to get that y dy equals negative x dx. And we can integrate both of those things. All right. Negative out of the way. So this becomes y squared over 2 equals negative x squared over 2 plus some constant, and that constant's going to change. So we're going to call it c1. Okay. Going to multiply through by 2 to clear out the fraction. So we're going to get y squared equals negative x squared plus some other constant now. Okay. And then finally, let's get it all into one place. Add the x squared in there. X squared plus y squared equals, well, my final constant. And you might recognize that as the equation for a circle. Okay, x squared plus y squared. I normally write it as equals r squared. R squared is some constant because the radius of a circle is constant. So what we saw in these slope fields was a bunch of what would emerge, what's going to turn into a bunch of circly sort of deals. Okay, and the equation is for circles. So it's not just a mere coincidence. Okay, slope fields, just basically, we're just trying to get a picture of a series of differential equations. Oh, the timer's been out there the whole time. That's kind of freaky. But we'll roll with it. There's that. And there's that. We're back to that thing. Is it a fort and out near Savannah, someplace out in the islands? I just like to picture the spirally case and the stuff. I don't know if it has anything to do with slope fields, but I just felt like the picture captured me. All right, anyway, there's that again. So differential equations, slope fields, they're sort of tied together. Now we've taken the mystery, hopefully, out of it. It's really not that big a mystery. You just put a bunch of dashes that have the right slope onto your thing. All right. Hey, thanks for watching. See you tomorrow. See you next time. If you have some questions, you let me know. Hope you learned something. Bye-bye.